Now, in this video, we are going to take up one more problem on projections of laminas. How to analyze and solve this problem by using the sketchbook. The problem number 99, and it reads as a regular hexagonal lamina of sides 30 mm is lying in such a way that one of its sides touches both the reference planes. If the lamina makes 60 degrees with HP, draw the projections of the lamina. He says a hexagonal lamina of 30 mm sides lying in such a way that one of its sides touches both HP and VP. So one of its sides touches reference planes means it is touching both HP and VP, and since the surface of the lamina is given with respect to HP, obviously we have to start the lamina from the HP. So here one of the side touches both the reference planes. Since one of the side is touching both HP and VP, obviously the side which is touching HP we need to keep perpendicular to VP. So that is the reason why we have to place the hexagon in this particular fashion, wherein the side is perpendicular to VP. So as we see from the front view, all the sides is parallel to VP. Therefore, when you look from the top view, you are getting the true shape. So each side will going to have a side of 30 mm. And as we see from the top view, the surface is perpendicular to VP. So in VP, you are going to get a line. So as you see from the top view, A, B, B, C, D, E, F, all the sides will be having the true length of 30 and all the points are visible. As we see from the front view, A, B, C is near to the observer. So A dash, B dash, C dash is visible and D, E, F is away from the observer. Therefore, D dash, E dash, F dash becomes invisible. So this is by using the 3D analysis. In 2D analysis also, if you see here, the side which is resting on HP has to be perpendicular to VP. Since it is a hexagon, so there will be two sides which are perpendicular to VP. So here, and as you see in the top view, since all the sides are parallel to HP, so we are getting the true shape in the HP. And as you see from the front view, all the sides are parallel. So therefore, in HP, we are going to get the true shape. As you see from the front view, since ABC is near to the observer, so A dash, B dash, C dash is visible and D dash, E dash, D, E, F is away from the observer. Therefore, D dash, E dash, F dash is in bracket. As you see from the top view, since the surface is perpendicular, so in vertical plane, you will going to get it is a line. Now the lamina makes 60 degrees to HP. So here we are resting CD on HP and makes the surface inclined at 60 degrees to HP. Once the surface becomes inclined to HP, but still the surface is perpendicular to VP. So that is the reason why we are getting a line here. As we see from the front view, ABC is near to the observer. So A dash, B dash, C dash is visible. D, E, F is away from the observer. So D dash, E dash, F dash becomes invisible. So this is how the surface will be perpendicular to VP. So when you look from the top view, you can see A dash, B dash, B dash, C dash, all the sides, all the points are visible when you look from the top view. When you look from the front view, A dash, B dash, B dash, C dash, then D dash, E dash, E dash, F dash, all are inclined to HP. Therefore, AB, BC, DE and EF will be in apparent length, and A dash, F dash is parallel to HP and perpendicular to VP. So that is the reason why you are getting a true length in HP. And similarly, C dash, D dash will going to have the same reason. So this is how you will be able to analyze in 2D and also on 3D. Now, in such a way that one of the side touches VP, both the sides HP and VP, the side which is touching HP is C dash, D dash. How do I know that? When you see from the front view, you can see that the side which is touching HP is C dash, D dash, and that side is perpendicular to VP when you look from the top view. But actually he wants that also to be touching HP, so touching VP. Therefore, we need to rewrite the same sketch by rotating at an angle of 90 degrees in a counterclockwise direction. So that you can see that you reproduce the second position top view here in the third position such that the CD is touching VP, and then write the corresponding front view. So that is how we can see in 3D analysis. Also here CD is touching both VP and also HP. And then And when you look from the top view, this will going to be the final position of the top view. And when you look from the front view, this will going to be the final position. So this sketch and this sketch is one and the same. So this is how you will be able to analyze this problem in 3D and 2D analysis. How do I know that my problem is right? We can see that one of the sides is touching both HP and also on VP, and the side and the surface of the lamina makes an angle of 60 degree with HP, and this is a hexagon of 30 mm side. Now we will try to solve this problem using the sketchbook. So to do that, so first we will going to take the center of the sheet and draw an XY line with a thin line, and you mark XY and VP and HP here. As we see, one of the side touching both HP and VP, the side which is touching HP has to be perpendicular to VP. So you need to get the two sides should be perpendicular to the XY line in the top view. So to do that, so by using the compass, you measure a distance of 30 mm, consider any center and draw a thin circle, and then draw a vertical line such that it touches the diameter of the circle, and you mark those 2 points as B and E. Now with B as center, taking the radius of 30, cut an arc on the circumferential of the circle at the bottom side on the left side, and similarly cutting on the circumference of the circle on the right side, and you mark those 2 points as A and C. Similarly with E as center, taking the radius of 30, cut on the left side on the circumference of the circle, similarly on the right side of the circumference of the circle, and you mark those 2 points as D and E, and join A to B, B to C, C to D, D to E, E to F, and F to A with a dark line. Then draw a vertical projector from A and F to the XY line. Similarly, draw a vertical projector from B and E to the XY line, and also from C and D to the XY line. As we see from the front view, ABC is near to the observer, so you mark them as A dash, B dash, and C dash, and D, E, and F is away from the observer, D dash, E dash, and F dash in bracket. Then join A dash to C dash with a dark line. So this will going to be a continuous dark line. So now, since we want a C dash, D dash has to be resting on HP, either we can rest it on A dash, F dash, or you can see that on C dash, D dash. That is basically because here the two sides are perpendicular to VP. So we are resting on C dash, D dash on XY line, taking any convenient distance from the first position front view, and you mark that point on the XY line, and you mark them as C dash and D dash in bracket. Then by using the protractor with C dash, D dash as center with respect to the XY line, you measure an angle of 60 degrees and draw an inclined line. Then by using the compass from the first position front view with C dash as center, measuring the radius of C dash A dash with C dash as center, cut an arc on that 60 degree line. Similarly, you measure the distance from C dash to B dash from the first position front view with C dash as center, cut an arc on that 60 degree line, and you mark them as A dash and F dash, and B dash and E dash. Then join A dash to C dash with a dark line and show the dimension of 30 here, 60 degree here. So here, this is how you will be able to produce the second position front view. Once you do that, to this we need to write the top view. So draw a vertical projector from C dash and D dash to the XY to the top view, and similarly from A dash and F dash. Then draw a horizontal projector from A and C, and similarly from F and D. Both these two lines will going to intersect at A and C here, and also F and D here. Then mark them as A, C, D, and F. Then draw a vertical projector from B dash and E dash, and draw a horizontal projector from B and E from the first position top view. Both these two lines will going to intersect at this point and also at this point. You mark them as B and E. Then join A to B, B to C, C to D, D to E, E to F, and F to A with a dark line. Then we need to, this is how you will be able to produce the second position top view. Now, as the side is resting on HP, the same side has to rest on VP. The same side now is perpendicular to VP. Now we rewrite the same sketch by rotating at an angle of 90 degrees in the counterclockwise direction. So to do that, by using the compass, you measure the distance from C and D from the second position top view and take any convenient distance from second position top view and mark it on the XY line, and you mark them as C and D. Draw a vertical projector draw a perpendicular line from C and also from D below the XY line. Then you measure by using the compass, you measure the distance from C to A, which will be same as D to F. With C as center, cut an arc on this perpendicular line. Similarly, from D also you cut an arc on the perpendicular line, and you mark them as A and F. Similarly, you measure the distance from C to this point, which is the same as from D to this point, and transfer from C onto this perpendicular line. Similarly, from D also onto this perpendicular line. Then join these 2 points and extend it on either side. Then you measure the distance from this point to E, which is same as from this point to E. So then with this as center, cut an arc on this horizontal line, and similarly from this point, cut an arc on this side. Then mark them as B and E. Then join C to D with a dark line, D to E with a dark line, E to F, F to A to B, and B to C with a dark line. So this is how we will be able to reproduce the third position top view. And now we want to project the front view. So to do that, since it is C dash, D dash is on XY line and CD is also on XY line, you mark them as C dash and D dash in the front view. Then you draw a horizontal projector from B dash and A dash, and draw a vertical projector from B and E. These 2 lines will going to intersect at this point. You mark them as B dash here and also E dash here. Then draw a vertical projector from F and also from A to the front view, and draw a horizontal projector from the second position front view from A dash F dash, and these 2 lines will going to intersect at A dash here and F dash here, and mark them as A dash and F dash. Then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash to F dash, and F dash to A dash with a dark line. So this is how you will be able to complete the final solution by drawing by using the sketchbook, and show the dimensions of 60 degrees and also 30 mm. And how do I know that my problem is right? The side which is resting on HP, one of the sides is touches both HP and also on VP, and the surface makes an angle of 60 degrees, and this is a regular hexagon of 30 mm. So since we are satisfying all the conditions given in the problem, and hence the problem is right. Thank you.